So for this problem, we're going to look at a differential equation from 2011. In here, we are given the dw dt equals to 1 over 25 times w1 as 300, and A says use a line tangent to the graph at this to approximate the amount of solid waste first 3 months of 2000 at time t equals 1 over 4. So we have to find the equation of the tangent line, a traditional question, at time t equals 1 over 4. So to do this, we are first going to plug in the number we're given. So here unlike the regular equations, we're not given y and x. We are given w and t, which is dy dx, so w and t, and we are given a t equals 0. So we're going to find the slope at t equals 0, which is w of 0 minus 300. So w of 0 is when time is 0, and in here it says at the beginning of 2010, which is time is 0, the landfill contained 1400 tons of solid waste. So w of 0 is 1400, and then minus 300. What's 300? 300 is just in the equation. Okay, go with this, and when you calculate it, you get 44. So 44 is our slope. And now we're going to write an equation and then plug in 1 over 4 to get our number. So w equals 1400 is the initial we started with, and then 44t. So w of 1/4 equals 1400 plus 44 times 1/4 equals, and don't forget the units, tons, because we're trying to find the amount of solid waste, so it's tons. So that's the answer to A. Now let's look at B. B says find the slope of dw dt in terms of w, and use the slope to determine whether your answer in part A is an underestimate or an overestimate at the time t equals 1/4. Okay. So another traditional question, find the slope of dw dt. So here we're gonna write the equation first. So in order to find the derivative of this, we're gonna try to use implicit differentiation. My pronunciation is incorrect. So 25 from 300. Okay, here we go. Now let's take the derivative of this. So d squared w dt squared. The derivative of this is so the derivative of this is 0, and the derivative of this w is, we're given the w is dw dt. Now we are going to plug in for dw dt. So we know dw dt is 1 over 25 times this. So we're going to plug in this for dw dt. So we go from one step to another. So just from looking at this, we know instead of doing the calculation, because we don't have the calculator, this is a no calculator problem. So we're not gonna go as far to do the whole calculation because we don't have that much time in our hand. So we just know that this is gonna be a positive number. So, and they asked us at time 1/4, right? So this is gonna be a positive number. So it's gonna be bigger than 0. So now we can say that therefore d square double dt square is concave up because it's positive. And so the tangent line is below the curve, and thus it is an underestimate. It is an underestimate. So where did we get this? This is the rule. Underestimate. This is the rule we have to. This is let's just say the rule we have to remember when we do a differential equation. If it's positive, it's concave up, so the tangent line goes below the curve, and if it's concave down, that means this is going to be negative, so the tangent line goes over the curve. That means this is an overestimate and this is an underestimate. So this is what we have to remember when we are asked to find if it's an underestimate or an overestimate. Now let's look at C. C says find the particular solution to W to WT to the differential equation dW over dt times over equals this with the initial condition W0 and this. Okay, so we have to use the initial condition of this, and we have to find basically the solution like we do in regular questions. Okay. So we have dW dt, and then we have our equation. So we're going to separate them. We're going to take this to this side, so we have all the w's on one side, and multiply by 1 over the opposite. Times dt. So always remember to separate it correctly, because if you separate it incorrectly, you get the whole problem wrong. And now we're going to integrate them to get the antiderivative. The antiderivative of this is natural log of w minus 300. Antiderivative of this is 1 over 25x, t, in this case is t, plus c. So we have natural log of 1400, because we're going to, okay, so I think I'll do the c here. I'll do c here. So we'll do here. So we're going to plug in the numbers they gave us, 0 for t and 1400 for w. So natural log of 1400 minus 300 equals, what is it? 1 over 25 times 0 plus c. So now we get natural log of 1100 equals c. So now we have our c. Now we can plug in c to get w. Natural log of w minus 300 plus 1 over 25 t plus natural log of 1100. So we take it to the power, we raise it to e, and we get rid of the natural log. So we have w minus 300, and then we have e to the power of 1 over 25t plus natural log of 1100. Now we need to get rid of this 300, so we're going to add 300 to both sides, and we get w equals 1 over 25t plus natural log of 1100 and plus this 300. This is your answer to C. This includes a question for differential equation. Thank you for watching.